Let's go over this Jamboard practice assignment for 2-4, day 2, on solving multi-step inequalities with variables on both sides. For number 1, which is number 4 on your homework, our first step would be to combine like terms. -6 plus 7 plus 3 is positive 4. Now we want to collect variables to one side. I prefer collecting them on the left side and constants on the other side. So to do so, I want to be able to move this positive 3x to the left. So I'm going to subtract it to move it over. (4x minus 3x is 1x. So we're left with x minus 4 is less than 4. So our last step would be to add 4 to both sides. And our solution is x is less than 8. Fill out your number line. We would want it open at 8 because 8 is not included. And it's all values less than, so we shade to the left. With number 2, our first step would be to distribute -3 times 5x minus 2. -3 times 5x is -15x. -3 times -2 is positive 6. Now we want to collect variables to one side, constants to the other. So I want to have this -6x. I want to move it to the left side. So because it's negative, I'm going to add it. -15x plus 6x is -9x. Our next step is to be able to move this -6 over to the right. Sorry, the positive 6 over to the right. To do so, I'm going to subtract it because it's positive. -30 minus 6 is -36. And our last step is to divide both sides by -9 because we're multiplying x by -9. And it's that step there that requires us to flip the inequality symbol because we divided both sides by a negative number. It is going to be filled in or closed at 4 because 4 is included in the possible solution set. And it's all values greater than, so we shade to the right. With number 3, our first step is to distribute on the right side 7 times 3x minus 1. 7 times 3x is 21x. 7 times -1 is -7. Now we want to collect variables to the left side, numbers to the right. So because this positive 21x is positive, to move it over, I need to subtract it. -5x minus 21x is -26x. Right now, to the x term, we're subtracting 7. So to solve for x and to isolate for x, I need to add 7 to both sides. -7 plus 7 is 0. So it looks like we're almost done, but we really, in order to solve an inequality, we need to have the x, whatever the variable is, we need it isolated. We need it by itself. So we're not quite done yet. Right now to x, we're multiplying x by -26. So we need to divide both sides by -26. And it's that step there that requires us to flip the inequality symbol So it was less than, it's now going to be greater than. And 0 divided by negative 26 is just 0. Zero is not included, so it's open or not filled in. And we flipped it, so it's now greater than, so we shade to the right. So 0 can still be a solution. It's just we want to make sure we go until x is completely isolated like we have as each of these solutions. Now for the word problem. We first want to write an inequality that represents the situation, and then we'll solve it and interpret it if needed. So an amusement park charges $32 per person for admission and $6 to park the car. You're only going to take one car. So that's a one-time fee. We want to find the maximum number of people that could go for $166. So remember, this is a spending inequality. So what you spend has to be less than or equal to what you have. So to set this up, we want to take the cost per person, multiply that times the number of people, add the one-time fee of the to park the car, we know this has to be less than or equal to our total amount. So the piece that we don't know is we don't know the number of people. So we're going to let x equal the number of people. And then fill in the rest of what we know. So the cost per person is $32. Number of people, that's x. $6 to park the car. And our total amount we can spend is $166. So there's our inequality that represents the situation. And now we'll solve. So subtract 6 first. And divide both sides by 32. So x has to be less than or equal to 5, meaning at most you can bring 5 people. That's it for the Jamboard practice assignment for 2-4, day 2 on solving multi-step inequalities that have variables on both sides.